Hey folks, Ms. Gosling here. In this video, you are going to learn about power. By the end of the video, you'll be able to define and solve problems involving power. Now, to clarify, I mean power in the physics sense, which we're going to get to in a moment, not power in the President of the United States sense. So we're not talking about political power or the power you get because of having money or connections. We're talking about the physical power output that you have. And to do that, we're going to use the equation on the bottom here, power, which we measure in watts, represented by capital W, is equal to the work done in joules, of course, divided by the time it takes in seconds. So let's go ahead and get some practice using that equation. So you lift a 5 kilogram box up 100 meters in 1 minute. So 5 kilogram box, 100 meters, 1 minute. How much power did you output? Here's my box with its mass of 5 kilograms. And I'm going to lift it up 100 meters. And the time is going to be 1 minute or 60 seconds. And note, guys, I do need to make sure that my time is in seconds because that is my SI unit. So let's go ahead and figure out this problem. So I know those three things that I just mentioned. My mass is 5 kilograms. My height, the distance, my displacement is 100 meters. And the time that takes me to do that is 60 seconds. And again, I know that because 1 minute is equal to 60 seconds. My unknown, of course, is power. So what I'm going to need to do is take my equation, power is equal to work over time, and replace work with things from my givens. So I know that power is equal to work over time, and work is equal to force times displacement. And since all of my force is going to be parallel to my displacement in that same direction, that means that all the force that I apply to this box does work. I know that because there's no angle mentioned. So my power is equal to force times displacement over time, or my power is equal to mg times displacement over time. And again, this is all going to be positive. And I know that because I'm moving my box up, so I'm increasing its energy. Now you'll notice, instead of talking about this from a work equals force times displacement standpoint, I could also talk about this as a change in energy, or my mg times my final height minus mg times my initial height, which is 0. And that is going to get me the same answer. So either of these approaches is fine. It's which one makes the most sense to you. So which one is going to make it easiest for you to solve a problem. Some of it as well is which is going to make the most sense with a problem. So if we have something speeding up, for example, looking at the change in energy is going to be more beneficial than looking at work because it's easier to measure change in energy than it is to measure work in that situation. Anyhow, moving forward, now that I have an equation that only includes my givens and my unknown, I am ready to sub and solve. So what I will write then is that power is equal to 5 times the 9.8 times 100 over my time, 60. And when I plug that into my calculator, I will get that your power output was 82 watts. And there you have it, guys. That is the solution to our first problem. Now let's try something a little more complicated. Jim merges onto the highway, doubling his velocity. If his car has a mass of 1,500 kilograms, his initial velocity is 10 meters per second, and it takes him 1.5 seconds to accelerate, how much power did his car output? So let's start by drawing a picture. Jim is traveling at 10 meters per second. And then, and he's driving his car of mass 1,500. Then, he speeds up. And by the end of our story, he is traveling at twice that velocity, or 20 meters per second. And his car is, of course, still going to have that same mass, since its mass is not changing. And that whole transition is going to take him 1.5 seconds. So let's figure out his car's power output. And of course, we're going to start by listing out our givens. So I know that the mass of the car is 1,500 kilograms. I know that its initial velocity is 10 meters per second, and that its final velocity is 20 meters per second. I also know that this change in velocity takes 1.5 seconds. And I can list my unknown as power, since that is what the question is asking me to find. So, my equation here is going to be power is equal to work over time. And instead of expanding this out to work equals force times displacement, looking at my information, the information in my givens, I know that that's not going to work because I don't have any forces mentioned. I don't have any displacements mentioned. So instead, I'm going to use the work energy theorem to expand this out, saying power is equal to my change in energy over time. My car is not changing its height at all. It's not, there's no springs involved. So the only thing I need to think about then is my kinetic energy. And all to say is that power is equal to my final kinetic energy minus my initial kinetic energy over time. And plugging in a few more numbers, power is equal to 1/2 times my mass times V final squared minus 1/2 times my mass times V initial squared, again over my time. And finally, my last set of simplifications before I plug in any numbers, I'm going to factor out the 1/2 m and say that my power is equal to 1/2 m times my final velocity squared minus my initial velocity squared over time. Now, that stuff is not necessary, but it does make it easier to avoid making mistakes because you don't have to worry about plugging in numbers wrong multiple times. You do have to think about your parentheses there, though. Regardless of whether you choose this option or this option, whether you choose to factor or not, it is time to sub and solve. So power is equal to 1/2 times my mass times my final velocity squared minus my initial velocity squared, all over 1.5. And when I solve that, when I throw that in my calculator, I'll get that my power is equal to 150,000 watts or 150 kilowatts. You do not need to change your units at all. I personally find that kilowatts is easier to use than watts a lot of the time because usually our power outputs can be pretty high. There you go, guys. That's going to be the solution to example 2. Now, let's take a look at an example using graphs. So the graph to the right here takes place over 0.5 seconds. So let's see how much power was output to do this work. So we're going to start by calculating our work. And I know that the work done is equal to the area of my rectangle plus the area of my triangle. So it's going to be equal to the base of my rectangle times the height of my rectangle plus 1/2 times the base of my triangle times the height of my triangle. And the rest of the numbers I'm going to get from the graph. Base of my rectangle is 20 and its height is 100. So what I will say is that my work is equal to 20 times 100 plus, same thing for my triangle, so I know my triangle has a height of 100, and that's going to be the side that is going up from my right angle. And I know that it has a base of 10, since I'm starting at 20 and going to 30. So for the triangle, I will write 1/2 times 100 times 10. And from here, I can figure out the work done. When I do so, I will find that the work done in this graph is 2,500 joules. So now I'm ready to finish solving my problem. And from here, it should be pretty easy, right? Because power is equal to work over time. My work I have found is 2,500 joules, and my time is 0.5 seconds. Thus, my power output is going to be 5,000 watts, or 5 kilowatts. And there you have it, guys. Now you have learned how to solve power problems involving graphs. So, takeaways. First, power measures how quickly work is done. And we can use the equation power is equal to work over time to calculate our power. Sometimes we'll be expanding out work using work equals force times displacement. Sometimes we'll use work is equal to our change in energy to figure out what our work is. And finally, sometimes we'll use work equals area under force versus displacement graph to find our work. In all three situations, finding work is often one of the most complicated parts of calculating power. Because we have our work, calculating our power is pretty easy to do. Just have to divide by our time. So with that, I'm going to leave you to try solving some problems on your own. Best of luck and happy solving.